Hey guys, how's everything going? This is JSer. In this video, we're going to take a look at the template literal types. So what is template literal types? We have this string literal type, like this one, right? This is a string literal, so this type is not a string. You see, it's just not a string. It's just this word. And if we have a type, say this is a template string, we had world in it, hello world, so the greeting should be hello world. Well, it's obvious, right? It's straightforward, but this is a newly add features. Let's see what it is. One thing we need to know is that when we define like a equals hello, the type of a actually is not hello, it's it's hello, I'm sorry. Yeah, because it's const, it's hello. If it's not const, let's say a is hello, a actually is not hello, it might be a string. This is because a might be set to something else, right? So like world. So a, we can only be sure that the type of a is string. Okay, now let's have a b. We use a string rule. A world, it's the same, that b actually is string. We don't know a, what the exact a is, so we don't know exactly what b is. One thing to change this is that if we change it to const, it will be, a will be a constant, right? So string literal, so and then b, b is hello world, and we could use as const, and b would be hello world. Or we define as a const b, but still it should be, oh, if not here, it said this string. Interesting. Yeah, so we could say as const, and b would be, yeah, hello world. Now we're doing this type, right? So type world is world, and then type greeting, it should be hello world. Yeah, this is what we want. Obvious, no problem. Okay, now we have this lowercase string type. Lowercase, it's not some utility types that we can write by ourselves because it's intrinsic. Okay, we have this greeting and quiet greetings, lowercase greeting. Yeah. What is it? Let's take a look. So now you can see lowercase hello world, and this, you said ASCII cache key, uppercase string. This is string uppercase, and then we uppercase. We change it to ASCII key ID my app. Why? Because we this is the string and it changed to uppercase. Yeah. So we have this utility type lowercase and then capitalize, which will capitalize the string literal. Yeah, you can see that this is a small h. Now we have a big h. And uncapitalized converts the first character to a lowercase equivalent, and we have lowercase like this, and we uncapitalize, it will be, the first one will be small h, right? The first character in a string, so W is not changed, only h is changed to hello world. Well, this is something new, and it might be useful. Oh, I'm sorry. This is the interesting part. If this is union, it will be all the possible string literals as union. So email locale, it's welcome email, email heading, footer title, footer standoff. If we merge them into this all locale IDs, and it will give us this nice, you can see that it will do the loop for us and give us all the strings. Interesting. And this is very useful when we have multiple language support, and we have LAN, and we might need some other LAN fight properties like welcome email ID map to 3 en and also JA. Yeah, interesting. Okay, let's see the string unions in types. So what it is. For example, a common pattern is extend object based on the fields it actually has. So we have this function which adds support for an on function which lets you know when the value has changed. Okay, so this is the person, and we make it watchable, and the on first name changed, and we have new value. It's any, and console log new value. Like the key name is first name changed. It's not first name, so we could actually do what? We could use this template string type. So this is function definition. It's a generic, and so the object here is type, and we return the type itself by extending it with a property event source. I think this is something built in. Oh, I'm sorry. It's not built in. It's here, defined here. Okay. What we add is, it says on event name. Event name might include 3, right? First name or last name or age. So with string literal, it said if it is changed, and then call back new value any. And this value actually could be something else, right? Rather than any, we could derive it from these the type. We should say type and get the. How should we get the key? We could interesting. How should we get it? Call back new value. New value should be the string. Key of. We could use generic here. And yeah, I'm not sure, but I think it should be something like that. I think it's oh yeah, here. Right, it should be generic. Yeah, we change it to generics, and this key must be key of types, and it must be string. It shouldn't be symbol or number. And then the key, it's this changed. So we add this constraint to make sure that the key here, part of this key name, is the same as the key here. Yeah. Interesting. Use generics is very powerful. And if we define the function like this, the unsupported event name will be filtered out. Cool. And if defined like this, we even know that it's not any, right? It's not any. New name actually a string here. New age is number. It's no longer any here. Wow, this is interesting. How we can consider this is that the type, a generic. So on the event name, it must be the union, right? And union of the key of type, and then call back with new value. So the type of key. This will. This is actually will tell us the type of the new value when we call the first person, or when we call this function with this. This is because this is the first. We will be matched against this, and then we can extract the key, and the key is string of type okay, and the key could be used as a new value here. So the TypeScript would know that this new name is string. It's not new. It's not something else. Wow, interesting. Okay, so that's it for template literal types. I haven't used it before. I haven't used it yet, and it looks pretty interesting and not that troublesome. Yeah, hope you can take it and give it a try. Okay, that's all for this video. Hope it helps. See you next time. Bye bye.